Now that the glass has been smashed, it's time to convert the wine object into a fluid that can be simulated. The shattering glass and the bullet will act as colliders for the wine. At first, the fluid will be represented by particles that can then be surfaced to visualize the liquid. So let's go back to frame 1. Let's go to the object level. And here we're going to organize things a little bit. We've got our fracture and our wine glass there. We've got our wine here, and we've got our bullet here. Okay, so let's hide these two elements. We'll come back to those later, and we're going to work with the wine. Now, we don't want to work directly in this network. We're actually going to extract it out just so we have a fresh thing to work with. So we're going to go modify, extract, and that creates another thing. We can call this wine merge. That's an object merge node. And then up above, we'll call this wine sim. Okay. And we don't need to see the original wine anymore. We're going to work with the sim one here. Extracting things out like this just allows our original geometry to be sort of untouched, and we can do all of our extra work here. So in here, we're going to go Tab, Flip, Configure, Flip. We're going to place down a bunch of nodes. And these nodes are sort of pre-configured example of setting up all of this using this character here, which is represented by these nodes, which we don't need because we're not going to do that. We're going to take this wine merge and we're going to feed that into the wine boundary node there, and this is going to allow us to start exploring. So we're going to go to the flip solver and set the flip solver display. And here we can see there's our fluid, but it's sort of cut off there. And why is that happening? If we go on the flip tank, we'll see that it's being cropped because the tank, which is sort of this is where the simulation should occur, is not big enough. So there's a couple things we can set here. Let's set surface tension, and we're going to set that to about 500. And we're going to add an ID attribute. This is through the attributes here. We're going to add an ID attribute. That's critical, especially for later when we retime the simulation. So again, let's go back to the top here, and we want to create a bigger box. 40, oh, not 400, 40, tab 40, tab 50, and we're going to go 10, 15, 0. And what that does, that creates a box so that when the bullet hits it here, there's lots of room for spray to go all over the place. Probably made it bigger than we needed, but for now, that's a good thing. Now, particle separation, this is a volume. Particle separation decides how many grid lines there are in that volume. So, you could increase that if you wanted to speed things up, or you could decrease it if you wanted. Okay, so let's see what's going on now. And if we press play, we'll see that the fluid is just falling into nothingness. We can extend this. Let's extend this to 50, and then if we press play, you'll see this just disappears. It goes away. Oh wait, no, sorry. There is a built-in collision ground surface, and that's great. So that is there, but you'll notice that it's sitting under the ground. And the reason for that is on the flip solver, if we go to this collision ground, you'll see that the default was set to 0 - 2 for that configure flip. So we want to change that. Go back here and then try that again. And now we'll see that it's actually landing on the object there. Now, we don't just want to collide with the ground, we also want to bring in some other elements to collide. So between the flip boundary and the flip solver, we want to go Tab, Flip, Collide, and make sure we're connecting all three of the first three entries, and we get this flip collide here. Now, we're going to go into here, and we're going to put an Tab Object Merge. This is how we're going to get the other elements in. So we're going to start by bringing in the bullet out. And right now the bullet's sitting on the ground. Let's set the display flag on there. It's not doing anything, and that's because we need the transform to be into this object. And then once we do that, yes, it will be properly animated. And then we can add another object into here, and this time we're going to go and get the Wineglass fracture, glass sim out. And so we'll see that as we've got all of that. And this only covers the first 10 frames. Matter of fact, we should go back to only be doing 10 frames now. So we've got the bullet and that together, and we're going to feed all of that into the fourth entry here for the collide. Okay, and let's go back to frame 1 just so we can calculate that properly. Now after this, we're going to add a trail sop, and we're going to put that after this. And on this, we're going to say just compute velocity. That will help with those things moving properly. Now, if we go back to the flip solver, and just like we did with the bullet, we need some substeps, so we're going to add in some substeps there. And the collision, okay, we don't need to do anything there. We're just going to go to setup. We've got that set up. And now we can run a sim. Let's see how that goes. Now this is going to take a little bit longer because it's got to run the whole simulation of all the bits and parts connecting to each other and so on. So you know what, rather than waiting for it in this situation, you know what, we're going to escape. Go back to here. And we're going to go, there's a file compress node. This is something that we can change that to points. This is something where it tries to optimize the fluid for saving it on disk. And we're going to go to this file disk. We're going to right click on here, delete channels, change that to 10 because we only need the first 10 frames. We're going to change the name of this to Wine Sim and /geo/wine, and we don't need a version number. So what we're going to do is we're going to let the simulation happen here, and then we'll be able to scrub through it and get a feel for it. So let's save that to disk. Okay, so that took just about 6 minutes on my computer, and this we can begin to see that fluid explosion here. So now that it's been simmed out. Now we also want to see it surfaced, so we do that here by setting the display on here. Now let's just put a color node down, and let's change that to smooth shaded, okay, just so we can get a feel for it. And on this node here, let's change a couple things. Let's change the method, keep the method to average position. Average position. Turn off the union compressed fluid surface. And I think if we got rid of this CD there, then we would probably have, yeah, we don't need this color node there. Under output, let's in the filtering tab, so under here we've got the filtering tab, we want put dilate on and have it set to 2, and then smooth to on, and we're going to change this to Laplacian flow, and that'll just change it a little bit. And that'll probably have more to do. Some of these things are more about as it goes from frame to frame to frame through the simulation. This is going with the sim. So that goes there, and if we want to, actually, put a color node down there. What we could do is just maybe just change that to a purplish color, and then we can go up to here, and if we bring the Wineglass fracture in, you can get a sense of what that's looking like. at this point in the explosion. So there you go. We've now simulated the fluids. We simulated the glass, then the fluids. Now what we want to do is retime it to sort of bullet time. So we want the whole thing to explode, hover in time, and then pull back to its original form. So we'll see you in the next lesson when we do that. Thanks.